So not B until we do example 2. And then you can circle all 3's if you want, because you're going to get 3B after this example. So, divide, and this one says to write the division statement. Very please. And this one in the setup is going to add part 2. Add a 0 if a term is missing. So when I set it up, I'm like, oh nice, it's in order. So I'm going to get a 3x to the 4 and have a minus x cubed. But notice there's no x squareds listed. So we have to write 0x squared. And then plus 3x minus 20. So it was written in the right order, but this one had a term or a degree missing. So if a term or a degree is missing, we'll put a 0 in there just so that our columns match up. We're dividing by x plus 2. And we'll start with green. Oh, a 3x to the 4. Is there anything I could multiply x by to get a 3x to the 4? 3x cubed. So I write that above my cubed column. 3x cubed times x is 3x to the 4. Perfect. 3x cubed times 2 is plus 6x cubed. Put it in brackets and subtract. Negative minus 6 will be negative 7x cubed. And then we still have plus 0x squared plus 3x minus 20. Switch colors. Purple's next. I'm really quite happy that I'm remembering the order of the colors that I chose, and I haven't screwed up. Is there anything you could multiply x by to get negative 7x cubed? 7 squared. Negative 7x squared. And so it's nice that we added the 0 for the x squared because we have a column for it. And also it's nice that we added the 0 because when I multiply now, I will get my negative 7x cubed, but I'll get negative 7x squared times a 2, which is negative 14x squared. That 0 is important because when you subtract, now your like terms still line up. And 0 minus a negative 14 will give you positive 14x squared plus 3x minus 20. Do you guys remember what color I chose after purple? Almost was away. If anyone of you says, oh, I'm sorry, I couldn't do these questions, Mr. Chair, I don't have an orange pen. That doesn't matter. Everybody's okay? Don't have to use these exact same colors.
I'm quite confused by the 0x squared in the combination with like making it minus and everything kind of like.
Okay, so where did the 0 in the black, or what color are you confused with?
Yeah, just why is it 0 and like it confuses me with the function and like.
So
I feel like
in what we wrote as the setup,
yeah,
we have to add a 0 if a term or degree is missing.
I know that, but I don't.
Okay, so then in our question, notice it has x to the 4, it has x cubed, it has x and it has 20, but it doesn't have any x squareds. The original question has no x squared, so we had to add a 0 to hold the space for that. Right? In our rate.
Oh yeah, okay.
Because when we do our math in the purple, we get an x squared, and we need to subtract it from what was above, so having the 0 there keeps everything organized.
So if I have something like there, the 0 wouldn't be there, and we just wouldn't have, like, the 0 is only there for the x squared. That's the only thing it's
needs the 0. Sometimes there might be 2 things missing, you have to put 2 zeros in.
Okay, but you knew that up front, and that's why you just put it there?
Yes. I knew right away from the question there was no x squareds. Right? So I made sure I wrote the 0 in. We have this in numbers too, right? If I have $1,805, I have 1,000, I have 8 hundreds, I have 0 tens, and I have 5 ones. That would be $1,805. But in numbers, we always have the 0 there. You can't just be like, I'll just leave it out. Haha, here's your paycheck. You'd be like, wait a minute. Yeah, you shouldn't have worked that extra hour, put that 0 in. That would be like, That wouldn't be good.
Also, for the first rule that we got, that is the decreasing thing. That means like the four.
Yeah, 4, then 3, then 2, then 1.
Always like that.
Yeah, always like that.
Up you good.
Okay. So now we're on orange. Anything we can multiply the x by to get 14 of 14x. Students like this long division because it's not as, like, you don't have to understand quite as much as the trig stuff. Like, trig often had lots going on in every question. It's like,
It's easy.
so far so good, right? 14x times x. 14x squared. 14x times the plus 2. Plus 28x. Put it in brackets. Subtract. What are we going to get? This will be 0, 13. Minus 28, negative 25x. And then you still have the minus 20. What color did I choose after orange?
I don't think you did choose.
Never got past that. Now I'm like,
Blue.
blue. Blue seems, I've been using the blue pen the whole time and haven't done any blue. So let's do blue. And
25.
negative 25. Negative 25 times x, negative 25. And negative 25 times 2, negative 50. And subtract. Positive 30. That's your remainder.
Yeah.
Okay. View, zoom, entire page.
Remember that px equals.
Yeah, that's a good idea. I'm going to write our division statement, but first I'm going to let p of x equals, so my division statement I can go p of x equals the divisor, x plus 2, the quotient, 3x cubed minus 7x squared plus 14x minus 25, and then plus the remainder, which is plus 30.
That's one big statement.
That is a big statement. And if we were hoping we were factoring it, we failed because we have a remainder. Yes. Yes. Okay. Now, before we get to example 3. Doesn't work anymore. I think if I right click, it'll work. I'm going to group them all. There we go. I'm going to make this smaller so we can see it all on the page width. Now, mathematicians, look at this and say you're doing the same thing over and over and over again. There's certain things that always happen. Maybe we could create a shortcut. So, I'm going to show you the shortcut. Don't write it down, because if you write it down, you're going to miss what's happening. And I'm going to show you how you can get this answer maybe a little bit quicker. But I'm not going to speak while doing it. You have to see if you can figure out where I get numbers from and what I'm doing. Okay? Done. My answer is 3x cubed minus 7x squared plus 14x minus 25 remainder 30.
Alright.
Whoa! Yes. That is similar to your method, right?
Yeah.
Yes. This method is only going to work if you're dividing by something that's x plus or x minus. If I would take this same thing and decide to divide by x squared minus 3, you'd have to use long division. Or 3x minus 5, you'd have to use long division. Yes.
So I noticed that you used the 2 from x plus 2, but you made it negative.
Yes.
Why is that?
That's a great observation. So first of all, the black numbers, did you notice that the mathematicians just took the coefficients and said, if we just leave spaces, we'll know that this is the x4, x3, x squared, x, and constant. Saves me some time not writing it. Kind of nice. And Callan asks, why do we do the minus 2 instead of the plus 2? Okay?
Because the value that gives x plus 2 equals 0.
Okay? It is the value, it's the opposite, it's what makes it 0. Okay? What was something that you noticed when I figured out the bottom numbers? How did I get, for example, this negative 25 in blue?
You multiplied the yellow number next to the 14 by the negative 2 and then subtracted.
Okay, I got the negative 28, but how did I get this negative 25? 3 plus, I added those two together, right? Can you see that here, the negative 1, negative 6? I added those together. People make less mistakes adding than they do subtracting. In long division, you always had to subtract.
Oh, so you
Right?
made it negative
But
2.
by making that first number negative, by making it a negative 2 instead of a plus 2, instead of having to subtract, I have to add.
Yeah.
And I make less mistakes.
Alright.
How did you get the number down below negative 6 and 14?
So the 3 obviously comes down, because if it's just an x, it's going to be obvious that you need to multiply the 3 to get the 3. Right? When I underline that first number down and there's a 3, you have to multiply to get the 3. So that first number just comes down. What's nice about synthetic division is they say, well, these first ones always subtract to be nothing. We're wasting time writing them down. Instead, we're really looking at the 3 is going to multiply the 2 to get the 6. So that's why the 2 times the 3 gives us the 6. And then, with the negative there, we add instead. Okay, I'm going to draw some arrows here. This arrow hit the 3, became the 6. Then in purple, hit the 7, became the 14. Then in orange, the 2 hit the 14, became the 28. Then in blue, negative 2 hits negative 25, becomes plus 50. And that's what happened every single time. If you look at what's happening in long division, that second number, that's exactly the 7 hits the 2, became negative 14. But then you had to subtract it, so it became positive 14. Okay? And this is way quicker. And this is called synthetic division. Have I started the third video, or am I still on the second video? Oh, I don't even know.
I think it's the second video.
I don't know.
Mr. Jr.,
Yes.
I couldn't play with you at the beginning of the lesson, but I haven't played this part so
You can
you
leave.
have to leave in like 5 minutes.
We'll find out. We'll just keep the video going. If I didn't stop the last video, and I just kept going, then example 2 and 3 will be together in one video.
Alright, and what are the questions for this one?
Oh yeah, no, I haven't stopped the video. I'm pretty sure I haven't, because I haven't given you questions. So we'll stop the video. We should really debate whether we should stop the video or keep the video going for at least 2 minutes in this video. For example 2, the questions are 3b and